Hi everyone, and welcome to another exciting episode of Planetic. Today, we're diving deep into one of the most mind-bending and fascinating phenomena in the universe, black holes. These cosmic enigmas have captured our imaginations for decades, and despite all the research, they still hold plenty of secrets waiting to be discovered. First things first, what exactly is a black hole? In a nutshell, it's a region of space where gravity is so incredibly strong that nothing, not even light, can escape once it crosses the event horizon. That's right, once something enters a black hole, it's gone forever. At the very center of a black hole lies the singularity, where gravity reaches infinite strength, crushing everything into an infinitesimally small point. Now, you might be wondering, how did we even discover these cosmic beasts? Well, it all started with the brilliant mind of Albert Einstein. In 1915, he published his groundbreaking theory of general relativity, which revolutionized our understanding of gravity. Just a few months later, German physicist Karl Schwarzschild found a solution to Einstein's equations that described the gravitational environment around a spherical mass, like our Sun. But here's where things get interesting. Schwarzschild's solution had a peculiar quirk. At a specific distance from the center of the mass, the math went haywire. This distance, now known as the Schwarzschild radius or event horizon, was initially dismissed as a mathematical curiosity. However, as decades passed, physicists realized that if you could somehow compress all the matter of an object below this critical distance, gravity would become so overwhelming that the object would collapse into a black hole. It wasn't until 1968 that physicist John Wheeler coined the term black hole, arguing for their existence in the universe. Some astronomers remain skeptical, believing that the bizarre properties of black holes indicated a flaw in our understanding of gravity. However, the debate was settled in 1971 with the discovery of Cygnus X1, an intense X-ray source that could only be explained by the presence of a black hole. So, what exactly lies beyond the event horizon? Well, that's where things get a bit tricky. Since no light can escape a black hole, we can't directly observe what's inside. However, based on our understanding of relativity, we can make some educated guesses. According to the theory, the singularity at the center of a black hole is a region of infinite gravity. But here's the catch, we know this can't be entirely accurate because our current theories of gravity and quantum mechanics don't play nicely together at such extreme scales. In other words, the singularity is a clear sign that we still have some work to do in understanding the fundamental nature of gravity. Now, let's talk about how these cosmic monsters are born. The most common way we know of is through the death of a massive star. When a star at least 8 times the mass of our Sun reaches the end of its life, it forms a core of iron and nickel. The outer layers of the star then try to collapse onto this core, but they essentially bounce off, resulting in a spectacular supernova explosion. The force of this bounce can cause the core to collapse on itself, forming a black hole with a mass several times that of the Sun. But that's not the only way black holes can form. In the early universe, just fractions of a second after the Big Bang, random patches of space may have reached such high densities that miniature black holes, no bigger than a baseball, popped into existence. These primordial black holes could still be whizzing around the cosmos today. Additionally, massive clumps of matter in the early universe may have directly collapsed into black holes, skipping the star formation process entirely. These behemoths could have masses hundreds or thousands of times that of our Sun. Despite their name, black holes aren't entirely black. In the 1970s, Stephen Hawking discovered that quantum effects at the event horizon can cause black holes to slowly emit radiation, aptly named Hawking radiation. However, for a typical black hole, this emission is incredibly faint, about 1 photon per year. Given enough time, though, Hawking radiation can cause a black hole to evaporate and disappear. This leads to a major unsolved problem in physics known as the black hole information paradox. Since information can't be created or destroyed, what happens to the information that falls into a black hole when it eventually evaporates? Solving this riddle could be a one-way ticket to a Nobel Prize. Now, you might be tempted to take a trip into a black hole, but trust me, it's not a journey you'd want to make. For small black holes, the extreme gravitational forces would stretch you out like spaghetti, a process scientists have playfully named spaghettification, long before you even reach the event horizon. Larger black holes might allow you to cross the event horizon unscathed, but once you're in, there's no turning back. You'll be on a one-way trip to the singularity, where you'll be crushed into oblivion. So, how close is the nearest black hole to Earth? The closest known black hole, discovered in 2022 by the European Space Agency's Gaia mission, is called Gaia BH1 and lies about 1,560 light-years away. There could be closer black holes lurking in the cosmic shadows, but they're incredibly difficult to detect unless they're actively interacting with their surroundings or merging with other black holes, producing detectable gravitational waves. Black holes come in a wide range of sizes, from stellar mass black holes, which have masses of few to a few dozen times that of our Sun, to supermassive black holes, which can weigh millions or even billions of solar masses. These cosmic giants typically reside at the centers of galaxies, like the Milky Way's own Sagittarius A*, which tips the scales at around 4.5 million solar masses. The current record holder, TON 618, is a true monster, weighing in at a staggering 66 billion solar masses. Luckily for us, it's located over 18 billion light-years away, so we won't have to worry about a close encounter anytime soon. Black holes may seem like the stuff of science fiction, but they're very real and play a crucial role in shaping the universe we live in. From the depths of massive stars to the hearts of galaxies, these cosmic enigmas continue to captivate and inspire us. As we push the boundaries of our understanding, who knows what new secrets we'll uncover about these mysterious objects? One thing's for sure, the study of black holes is sure to keep scientists busy for generations to come. Well, that's all for today's episode of Planetic. We hope you enjoyed this deep dive into the world of black holes. If you liked what you saw, be sure to hit that like button and subscribe for more mind-bending content.